Hi, this is Chycho again. Now, what we've done in the last little while is, or the last few videos, is talked about equations and functions, and used a fair bit of new terminology that we didn't talk about in Series 1 and Series 2, right? So what I want to do right now is, take a step back and go define some of the terms that we've used and introduce some new terms that we are going to use, okay? We should have probably done this a little bit earlier, come to think about it, but it's always good to get your hands a little dirty before you go in and learn the specifics of something, right? You need to, just get in there and, play around a little bit and then take a step back and figure out exactly, what you were exposed to, right? So what I want to do right now is, define some of the terms that we've used and some of the terms that we are going to use, specifically terminology related to polynomial equations and polynomial functions, because it's polynomials is what we're, in this series really dealing with. And they're a huge branch of mathematics. Polynomial functions are one of the main types of functions that we use for our modeling, and it's one of the first types of functions that we began to use when we started modeling and trying to understand the world around us, right? So we might as well go back a little bit and define some of the terms and figure out exactly what it is that we are talking about. Okay, so I'm going to go back here and lay down the base for this thing, and after I'm done, we'll come back and talk about it real quick and figure out what it is exactly that we are doing, or where it is exactly that we are going, right? And what it is exactly that we are talking about. And again, these are just basically a specific type of function, one of the most basic types of functions, polynomial functions, which what they do is they're also referred to as smooth functions, because polynomial functions, give us nice curves and twists. They don't have any breaks in them. They don't have any holes in them. So again, that's why they call them smooth functions, because they're continuous. And that's what we are sort of learning in this series, and we are going to talk about non-polynomial functions, but again the main part of what we are talking about is going to be polynomial functions. So let's go back here, listen to a little bit of music, and once I lay down the base, I'll come back and we'll just talk about it a little bit. Okay, I got my tools here, so we'll see where we go.
I want to drop a new style of all the MCs. I call this the offbeat, on-beat style. See if you can swing with it. See if you can swing with it. They go like this.
Okay, so let's talk about this real quick, okay? We have the real number set that we talked about in the first series, right? We have the natural numbers, whole numbers, integers, rational numbers, and on this side, we have the irrational numbers, right? And if you don't know what this is and you don't know the subcategories, please review it's one of the first two videos in the first series because, again, super important that we mention everything that we do is going to be using this terminology, this category, these subsections to define what it is that we are talking about, okay? So, we have the real number set here, and in here, on this side, we have our polynomials. And polynomials are one of the main branches of functions. Polynomial functions and polynomial equations is a huge section in mathematics, and they're used to, or they do actually, it's not used to, what polynomial functions do is they graph smooth functions, smooth curves, without any breaks in them, without any holes in them, without any asymptotes, okay? So they're continuous functions with, fairly smooth curves. Actually, they are very smooth curves in them, okay? And that's called polynomial functions, if it's f of x equal to something like this, or polynomial equations, where it's not a function, where you're setting the function equal to 0, okay? Now, the way the polynomial functions work is, or polynomial equations work is, or polynomials in general work is you have this form. You have basically you're going to have ax to the power of n plus bx to the power of m plus cx to the power of l, where a, b, and c are the element of the real number set, so they could be anything from this group. Any number from this group. They could be rational, irrational, integer, whole number, or natural number, right? And the powers of the exponents, whatever the exponent is taken to the power of, they have to be from the whole number set, okay? They have to be either 0, 1, 2, 3, all the way up to infinity. You can think about it as positive integers, and whole numbers are positive integers, right? So for something to be a polynomial equation or a polynomial function, the power, the exponent, has to be a whole number. And that is a polynomial function. Now, the other criteria for the powers, for the exponents, is they have to be put in descending order. So if you had f of x equal to, x to the power of 5 plus x to the power of 6, you have to bring the x to the power of 6 first, and then x to the power of 5. So whatever power is on the x, the highest power goes first, and then descending power. Okay? And those are considered to be polynomial functions. Now, this is sort of a, some kind of terminology that I just put together to just simplify things, right? In mathematics, it goes a little bit more deeper, and the way they write out functions, polynomial functions, and they define things is a little bit more intricate because they want to make sure they cover all categories, all groups, right? So there's no confusion of what a polynomial function is and what a polynomial function isn't. So let me go back here, and at the bottom here, write down in mathematical terms what a polynomial function is. And it uses a few more letters and stuff like this, but basically this is what it's saying, polynomial